Okay, no problems. Then let's see example 6. Now example 6, example 6 is for you, these questions, we have A, B, C, D. A, B is for to find the velocity. C, D is find the time and also the accelerations. Okay, C, D, we will discuss C, D in next slide. Okay, so this is this actually is finding accelerations, but we find the velocity first. Okay, find the velocity first. Okay, now they say the ticker tape in figure above was produced by a toy car moving down a tilted runway. If the ticker tape timer produced 50 dots per second, means that the frequency is 50 hertz. So find the initial velocity. Now, if this is directions, means it moved to the right. If it moved to the right, this will be the initial movement, and this will be the end. Okay, move to the right. This is initial movement, and this is the end. Okay, so let's find the initial velocity first. Initial velocity u is equal to this a. Okay, displacement divided by time. Okay, now the displacement is equal to 3 cm for the initial movement, right? We take the first ticks, the first tick from here to here, 3 cm. Okay, and this is only one tick. One tick times 0.02 seconds. Okay, so this is equal to 150 cm per second. So that is the initial velocity. Okay, we take the distance traveled divided by the time taken. Time taken is one tick. One tick. So distance traveled divided by time taken. Okay, one tick. B, final velocity. So again, final velocity, we use the formula V equals to S over T. Now V is the displacement, which is 0.5, 0.5, and the time taken, one tick, 1 multiplied by 0.02, okay, which is equal to 25 cm per second. Okay, so that is the initial velocity and final velocity. It's very easy, right? We just take the distance and then divided by time. This one take distance divided by time. The time is one tick for this case. Then we get the initial velocity and the final velocity. Okay, as I told you, finding velocity is easy from ticker tape, but finding acceleration is quite hard. Okay. You can't say I didn't see directions. Do you see this arrow? You can. There's an arrow here, show the directions. Okay. Okay, so that is how we find the velocity. Yeah, okay. And always keep in mind, because a lot of students, they make this confused with these things, the directions. Okay, if we move to the right, this will be the initial movement, and this will be the final movement. So this is initial velocity, this is final velocity. If we move to the left, then it's the other case. Okay, the opposite. You move to the left, then this is the initial movement, and this is the final movement. Let's write here. Okay, our u is equal to 150 meter per cm per second. Sorry, yeah, cm per second, and v equal to 25 cm per second. Let me go back to see. Okay, yeah, cm per second, right? Cm per second. Okay, and then C, they want you to find the time taken for the velocity change from u to v. That is the problems for finding accelerations. Okay, finding accelerations. Time taken for the velocity change from u to v. Okay, now if you want to find the time taken for the velocity change from u to v, the first thing is you must know where is your u and v. Where is your u and v? Because some students, they just find the number of tick. Okay, they say, okay, time taken, let me find the number of tick. 1, 2, 3, 4, 5, 6. Okay, 6 tick. 6 times 0.02, so it's 0.12 seconds. Okay, now this is not correct. It's not correct. That is not how we find the times from U to V. Yeah? Okay. So to find the time from U to V, first you must know where is your U and V. Okay, where is your U and V? Yeah. Okay. Let's see. We have 3 position here. Okay, this is initial movement, right? Let's say this is A, B, and C. Okay. So let's try to make a guess to see where is the U. For this case, where is the U? Where is the U? Okay, A, B, or C? The positions of the U. Or all 3? Or all 3? Usually it cannot be all 3 because this one is undergoes deceleration. Means that the speed change, right? The speed here and the speed here and the speed here may be different. Okay. Ye Kan and Si Leong say A. Okay. Now, excuse me. This thing is undergo decelerations. Let's say at this point, the speed is 160. Here 150 and here 140. Okay. So, if you take the total distance from this dot to this dot, the total distance divided by the total time taken, which is 1 tick, right? What you get is the average speed. So your U, just now, for this case, okay, our U, we take the total distance divided by the time taken. This one actually is the average speed. Is the average speed. Okay, average speed. Okay, and the speed actually it decreased from 160 to 150 and 140. Okay, and for uniform accelerations or uniform decelerations, the average speed is in the middles. That is the speed in the middle. So this 150 is in the middles. Here 160. After that, it decreased to 140. Okay, so the 150 that we get is the speed in the middle. So it's the average speed and it's the speed in the middle for uniform velocity or uniform accelerations. Okay. So can you still follow me? Eunice, Ye Kan, Si Leong, Jimmy. Okay. So the U is in the middles, not here or not here. The U is in the middle. Why the U is in the middle? Because the U is the average velocity, and average velocity is in the middle. Is the velocity in the middles. Okay, here this is the highest, this is the lowest. Average is in the middles. Okay, so the U is here, is in the middles. This is our U. Okay, and same things go for the V. Yeah, the V is also in the middles. Okay, V is in the middles. So therefore, if you are asked to find the time taken from U to V, so you must start from here. Okay, U here, 1 tick, 2 tick, 3 tick, 4 tick, 5 tick. So the time taken from U to V is 5 tick, not 6. If you start from the first dot to the last dot, you will get 6 tick. Okay, but that's not correct, because U and V are average velocity and they are in the middles of the 2 dots. 5 ticks, 5 ticks. But sometimes some teacher, okay, they think to count it this way is a little bit hard for the students. Okay, so the teacher say, okay, now let's do this. Okay, say, let's count it this way. Let's count it from this dot. We start from here. So you say, okay, this is 1 tick, 2, 3, 4, 5. Okay, you see, what the teacher teach you is you ignore the first one. Okay, they want you to divide it. This is the one. Okay, so the teacher say, okay, we do not start from here to here, we start from this one. From this one, okay, we count 1 2 3 4 5. Okay, 5 ticks. Okay. So you can say we use a formula for finding acceleration. Yes, that's correct. Formula, we use the same formula, A equals to V minus U over T. Okay, yeah, we use the same formula. Okay, so you see that is how we count the number of ticks. Okay, for me, I will tell you to identify the U and V first, okay, and then find the number of ticks. But your school teacher may teach you another method. They say, okay, we ignore the first one. Okay, we let's start from here. Okay, so start from here and then count 1 2 3 4 5. Okay, do not start from the beginning, start from the end and then count 1 2 3 4 5. 5 ticks. Okay. Okay, so the time taken is 5 ticks. Time taken is 5 ticks. So for C, the time taken is equal to 5 ticks, and each tick is 0.02 seconds. So it's equal to 0.1 seconds. 0.1 seconds. Okay. So the last one, D. Okay, D is accelerations, right? Acceleration A equal to V minus U over T. Okay, final velocity minus initial velocity divided by time, right? Okay, so we already have our V, U, and T. V 25, right? U 150, and T 0.1. Okay, final velocity 25, initial velocity 150, and the time taken 0.1. So we substitute this V, U, and T into the equations, then we can find the accelerations. Okay, negative 1250 cm per second, or negative 12.5 meter per second. To find accelerations, we use this formula, A equal to V minus U over T. Okay, we can find U and V easily. The problem is the T. The problem is the T. So for accelerations, if you are asked to find the time, you must be very, very careful. Okay, very, very careful, because it's different from finding velocity. Finding velocity, you just count from the first dot to the last dot. Okay, but for finding acceleration, that's not the case. You must know where is your U and where is your V. Okay, U and V is always in the middles, in the middles of the length that you measure. For example, this one we measure 3 cm, right? Okay, then it's in the middles of this 3 cm. This one 0.5 cm, it will be in the middles of the 0.5 cm.